Arrangement in a circle. Let's take a look at how we can find the number of arrangements if they are arranged in a circle. Now, let's use a simple example. How many ways can 4 people be seated in a round table? Now, the keyword here is round table because if in a straight line, you would say, oh, okay, it must be 4 factorial if it is in a straight line or row, correct? Line or row, no problem, it's a 4 factorial. But in a round table, it's slightly different because in a round table, there is no absolute position, right? There is only relative position. So technically, my A, is it 4 factorial? It's not. Technically, if I say consider the first person A, whether this person is seated here, 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 or here, it doesn't matter. There is only relative position. So the seats are indistinguishable in a round table. All right. Provided they're not numbered or colored, we'll talk about that in a different scenario. But if the seats in a round table are indistinguishable, right, it doesn't matter where A sits. So the way to look at it is A is seated only one way, and subsequently, once A is seated here, you fix this A here. There's only one way to do it because it needn't matter where A sits. Then after that, you arrange B, C, D relative to A. So you arrange B, C, D relative to A like that. So therefore, the answer is one way for the A, then after that for the B, C, D to be arranged round A. Right? For the matter of fact, it could be A, it could be B, it could be C to be for the reference. It really doesn't matter. Your final answer must be, therefore, if you have n objects around a circle, it therefore must be 1 time for the reference, then times n minus 1 factorial. There's another way to think about it. There's an alternative way for you all to consider. Let's take a look at ABCD again. ABCD. Now, you consider if I use 4 factorial like that, right? I would have considered these 4 different cases, right? I would have considered all these different cases. And if I use 4 factorial, these 4, 1, 2, 3, 4, would have be treated as different cases when in fact they are the same. Because if you look at it very carefully, A, B, C, D, they are all in the same relative position. There's no difference. So therefore, instead of using 4 factorial, you will divide by 4. Why? Because you have, for every 4 case, correct? For every 4 case, they are actually the same. So therefore, it's back to our n minus 1 factorial ways. So pictorially, it's like that, right? If you can see here, A, B, C, you can see A, B, C, D is the same as A, B, C, D like that. So you collapse them, correct? Yes, you collapse them like that. And then similarly, for this case, A, B, D, C, A, D, C, they are all collapsed. So for every 4 case, they are actually the same case. So therefore, that is the illustration that can help us a little bit. So essentially, just remember, if you have n objects in a circle, so it's actually 1 times n minus 1 factorial. Some of us may just write n minus 1 factorial. These two are okay. Right, thank you.